Physics. There's really two types of physics: theoretical and classical. And did that help? But to my understanding, those are the two prevalent forms of physics: theoretical and classical. Classical physics is what actually describes the world we're in. It can describe why, when you walk into a wall, it has the same effect as somebody else walking into a wall. Classical physics involves the measurement sciences themselves. This is the aspect I learned it from. So what does that mean? Classical versus theoretical. It's a poor analogy, but it's fiction versus nonfiction. In an abstract kind of way, you can say that. Or as a joke, it's humor under your voice, right? Muttering to yourself. That's not classical. But classical physics isn't that classical you think of, because physics grows, ages, matures. It has, with time and our understanding of how to use equations to describe reality itself. So that's classical physics. Once sat in a class about 4 weeks, and all we talked about was an equation. PV equals, or PV equals nRT. Now notice I didn't say PV equals T. I put nRT in there, because those matters in just some rooms and some places and some times, and a lot of engineering. Phase change causes angst in that simple equation of PV equals T. So anyway, in this class, we were looking at P and V and T and how we measure them. In this class, I learned about absolute temperature scales versus relative scales. Scales that start at zero, that don't have negative numbers we know or understand or can use. Those negative numbers in an absolute scale would be theoretical physics. So classical physics has done a bang-up job of describing the real world. Not as a religion. It's just a simple understanding of how things work, to details, to precision that most people don't care about, don't worry about. So you sit in a class for weeks. And half of the class is classwork, where you sit and see equations drawn on a blackboard that support the theories and the ideas of P or V or T. All of them extremely complicated in their own details. People could spend a lifetime trying to study one. So what did we talk about? One of the interesting things in trying to create a vacuum to get to an absolute zero is the theory of absolute zero. This is where problems come in, because there's boundaries to what we know, and at those boundaries we have a lot of questions to answer. So when you get to that zero, so we evacuated a chamber to the best of engineering abilities, science abilities today, and could not get to absolute zero. So when we looked at it, the physics of the pump itself was not able to get to zero. Just discrete analysis of the pump itself showed it couldn't get to zero. But then there are theoretical problems inside that chamber you're trying to get to zero. Zero, in scientific terms, does mean a lack of everything. It's a theoretical concept, so far from where we operate in the world that Not many people poke at it. So in that classroom, there was every service that's available in the United States, and even some foreign services sent people to these schools. Learning how to read pressure gauges, temperature gauges, learning how they work very precisely, why they work, why a thermocouple works, why a thermometer works. At the end of the course, you were given the ability to sign those little stickers that you might have seen on test equipment in labs. Just a little, probably initials and a date and maybe a sequence or serial number tied back to the lab work done. So those stickers matter to some people, some they don't. You don't see them on consumer goods. Very few people send their meters out to be certified or calibrated. But that absolute zero idea, where did it go? Well, because we had a steel chamber, a vacuum chamber, meant to test out maybe the vacuum pump, maybe the pressure gauge, maybe the vacuum gauge in this case, trying to get to an absolute number. But when you get to that, again, boundaries, to achieve absolute zero means there can be no energy in the system. Zero energy, another absolute scale. Which means there can be nothing there. This is the theoretical nothing that people speak to, speak around, speak about, use to say some things aren't true, when we just really don't know very well. So this classical physics versus theoretical physics is an important line to be able to understand, not believe. It's just a simple understanding. We get into trouble at the extremes of what we know. So theoretical physics, where is that in our life? We only know one universe. That's a challenge. That's a problem. That's an issue. That's a concern. It does not matter in the least to daily life. You have to have faith that the universe will be here tomorrow. So theoretical physics delves into those questions, has talked about other universes, the possibilities of other universes. What's on the other side of the nothing that supposedly started our universe, the only one we know, the only one we can touch and measure and look at. And boy, have we looked at it, and we're still looking at it. Space, another frontier. So theoretical physics is both amazing and confusing. It can be used to make crystals into magic, to dilute frequencies into nonsense, because it takes an education, whether it's self-taught, classroom taught, it takes some knowledge of the difference in these conversations. And it is science fiction versus nonfiction. And what other shelves are in the library? That's the Dewey Decimal System at work, by the way. So, why does this matter? Why does this conversation matter? These are the questions facing humans. What is our planet going to do? Can we conceptualize that humans have been at the whims of this planet in the hundreds of thousands of years that we've been here? That one civilization in one specific place was not unique or special to the human experience. So, theoretical physics, what does it mean to you? Where do you draw the line? Again, the disassociation in a perfect vacuum of whatever contains that vacuum. The very molecules are going to disassociate from the wall of that chamber. So how do you account for that when hunting for absolute zero? It was amazing thoughts. Homework was going to our national labs and talking with scientists and engineers there. Most all of them were engineers doing science. So, peace is out.